A very good morning, my dear students. So today we are going to start that we are going to focus on the bent rule. What is this bent rule? In the CBSE, it is not much more explained, but this will help you to know the position of lone pair and the position of more electronegative element in any structure. After the hybridization, you should know the bent rule, and this will make your work easy to place the lone pair of electron and the more electronegative element in any bipyramidal structure, and mainly it is used for TBP, trigonal bipyramidal. So what this rule says? So first of all, few points I have written that is important. You should know this. In the TBP, that means trigonal bipyramidal, lone pair always prefer to stay at equatorial position. And you know that the equatorial position, if I am drawing like this trigonal bipyramidal, this is the A and here. So this one is called equatorial position. This one is called equatorial position. Got it? So always lone pair always try to or always prefer to stay at the equatorial position. What is the reason behind it? Because in this it is getting more space. You see, this is the 120-degree angle. It is going to get more space over here. Okay, but if you keep in this way, it is 90-degree angle. This is 90-degree angle. So that's why lone pair prefer to stay at the equatorial position, and the high electronegative element will stay at the axial position. Axial position is this one. Okay, so all the high electronegative element jo hoga, that we will keep on the axial position, while the if lone pair is there in the compound, we will put it in on the equatorial position. And why it is so, I have explained that because there is a more space, so easily accommodate ho jata hai. Few more reasons are there that I am going to tell you. Equatorial position has more percentage S character. How it is, that I will explain. Don't worry about that. So since it is having more S percentage S character, that's why the more electron cloud, and hence it will reside the nucleus. क्यों? क्योंकि percentage S character होगा lone pair, and lone pair जो होगा, that is more electron cloud. So electron cloud will very happily will will reside to near the nucleus, isn't it? Positive के पास ही तो रहेगा. So that is the reason, and that in that case it will be considered as the stable compound. Okay. So for a few more points, it is, if more percentage S character is there, then it will be more electron cloud, and that will be near the nucleus, and you can say that the more bulkiness group it will be. So needs more space. So that's the reason that I have explained over here. And if it is percentage P character, more percentage P character is there, then the bond will be thin. There will be thin and thin bond, and the shape structure will be longevity. That means the bond is going to be it will be elongated. Okay, elongated ho jayega. So how it's so? Let me explain that. Okay. So first of all, if I'm just doing this, like if I'm saying that PCl5, draw the structure of PCl5. All the bonds are same, all the bonding elements are same, so we will make the structure like this, PCl5 here, and this is in the center P, and here equatorial position, we will keep the chlorine over here like this, and this is the axial position, so we will keep all this. Got it? So this was so simple because all were same. What will happen if I am giving you another example like PCl3F2? Put the where you will keep, what will be the structure for this? If you can draw like this, see, we can make it like this, P over here, and then let me make it over here F, and then here F, and then Cl, Cl, Cl. What else I can make? I can make like P in this Cl, Cl, and Cl, and here F, and here F. Okay, what next I can do? I can do like P over here, and then it is like this is F, F, and here Cl, Cl, and Cl. This is like this. Yes, I can make it like that. So if you will go through with this and this structure is completely wrong. This is the correct answer. What is the reason behind it? First of all, the same line we have to understand that lone pair always lone pair है नहीं, so we will leave it. high electronegative element will always stay at the axial position. So fluorine is, sorry, I made the structure wrong over here. This one is the correct. Okay, sorry. Okay, this one is wrong. Done with that? So fluorine is more electronegative than the chlorine, so that's why it should be on the axial position, isn't it? So that is the correct structure. Done. So this one will be there. What is the reason behind it? इसके पीछे क्या है? ये percentage S character and all that कैसे निकालेंगे? So let me explain this thing. Can we assume that sp3d is there? sp3d. Can I say it is sp2? Can I write like this? sp2 and pd? Any problem in this? We can write. So ये जो sp2 होता है, that will exist as a equatorial. Okay. Here some S character is there. You know, here no S character. So this will always exist on axial position. Got it? How much S character over here? Let me explain this thing. So S percentage ionic character or percentage S character can be defined as percentage ionic character or S character. Because more the S character, more will be the ionic character. So we can say like this: percentage ionic character or S character can be defined as cos theta is equal to S upon S minus 1. This S is orbital. Okay. This is the formula. Now, if I am talking about the equatorial position, so equatorial angle is 120, isn't it? All 120. So let me write cos 120 is equal to S upon S minus 1. And cos 120, we know that what it is? 1 by 2 is equal to S upon S minus 1. So what it will be? 2S is equal to S minus 1. So S will be 1 by 3. That means if we talk about the percentage, it will be 33.33%. Isn't it? And 33.3% किस में होता है? sp2 में. How? See, all together, any hybrid orbital, if we consider, it is 100%. Okay. So in 100%, 1s and 3p orbital are there. So if I will divide 100 by 3, we will get the percentage of each. So 100 by 3, that means it is 33.3. So S is only 1 over here. So that means S is 33.3 while P is 66.67. Isn't it? So here percentage S character is there. So 33% का मतलब क्या होगा? sp2, and that's why it will exist as a on a equatorial position. I hope it is clear. Let me check for the axial also. If axial, if we have to find, so for axial position, the same formula we will apply. Cos theta is equal to S upon S minus 1, isn't it? And for the axial one, what is the bond angle? What is the angle here? 90 degree, isn't it? This is 90 degree. So we will consider cos 90 is equal to S upon S minus 1. And cos 90 value is, we know that, 0. So S upon S minus 1, that means S is equal to कितना हो गया? 0%. That means on the axial position, there should be no S character. And you just check, I have given this PD. There is no axial पे PD रखा है, that means there is no S character. I hope it is clear. Any problem in this? Yes? So now, if in this basis, on this basis, if I will say that, draw the structure of PCl, like okay, PCl5. So it is same. There is same, no issue. Let me draw, and this is the, all the bond are same. So anywhere you can put. Okay, this is, and here in this case, if you check this, PD, that means P total is 100. So for P it is 50%, for D it is 50%, isn't it? So more percentage P. Yes, more P character. That means more thinness. So the bond will be longer, isn't it? So that's why ये जो bond होता है ये thin हो जाता है और ये long हो जाता है, and that's why ये अपनी तरफ attract कर लेता है bond को. Clear? Any doubt in this? Okay, one more thing I just want to explain here. On the axial position, the S is 0%. S is 0%. That means on the axial position, it will not feel any electronegativity of the central atom. So if I will ask that what is the what is the feeling for this feeling of electronegativity for this chlorine towards the central atom? So sent towards the central atom, this chlorine is not feeling any electronegativity, और ये आसानी से क्या होगा, स्टेबल होके वहां पे एग्जिस्ट करेगा. गॉट इट? समझ में आई बात? इज इट ओके? एंड दैट्स व्हाई अब यहाँ चीज मैंने बताया कि on this axis the p character is more, so that means the bond is going to be long, isn't it? And if more bond length, the stability will be less. We know this, we have studied this. So that is the reason that when PCl5 is heated, it will give you this PCl3, and these two, ये जो chlorine है axial position वाले, they come out as a chlorine. I hope it is clear. Yes? Any problem? Similarly, if I'm telling you to draw the structure of PCl3 and F2 and what will be the product on heating. So let's do this. Again, this is sp3d, isn't it? So if it is sp3d, we will draw the structure like this. This is P and here, and this is the axial position. So I have told you, out of chlorine and fluorine, which one is more electronegative? Fluorine. So fluorine we will keep on this, isn't it? And this is the chlorine, chlorine, chlorine over here. So what will happen when we heat? Because of thinness of this bond length is more, and hence will be easily broken. Yes. So when we will heat, it will give you PCl3 plus F2. The question can be asked that why not Cl2 is coming? Why it is PCl, F2 क्यों नहीं बन रहा है? Cl2 क्यों नहीं बाहर आ रहा है? So that is the reason. Did you get this? Yes. Because fluorine is at the axial position, and here the bond length is the maximum, and that's why the stability is least, and when we heat, it will be broken. Isn't it? Okay, very good. So now one more like other structure let me do. If I'm telling you to draw the structure of ClF3, what you will form? The hybridization is sp3d, there is no problem in it. Check it. Chlorine is 7, and this is also 7, 7, 7, 21 plus 7, 28 divided by 8. It will be 3 bond pair, 2 lone pair, isn't it? So that means 5, yani sp3d, yani it will also be TBP structure. Yes, and if it is TBP, we will draw the structure like this. Chlorine, and here this is. Now, in this case, there are the 3 bond pair and the 2 lone pair. So where we have to keep the lone pair? Lone pair always try to reside at the equatorial position according to Bent rule. Be very careful. Yes, lone pair को हम हमेशा पहले क्या करेंगे? उसमें देंगे उसको equatorial position पे we will keep. Prefer करता है. So we will keep the lone pair over here. Yes, and the 3 fluorine will be here. But due to this repulsion of lone pair bond pair here, what will happen? The fluorine will be little bent like this, and this will be called bent T shape. I hope it is clear. I have already explained in that hybridization, and this is the correct reason over here. Okay. Any problem in this? That's good. Okay. If I will say to draw the structure of XeF4, draw it fast. XeF4. Yes, Xe8 and 7 4 ja 28, 8 and 28, 36 divided by 8. That means 4 bond pair and 2 lone pair, isn't it? 2 lone pair. So what we will do? We will draw, this is octahedral. Yes, square बना दिया Xe, and as I told you, in this case, that lone pair will always reside on the equatorial position, isn't it? So we will keep it over here. Lone pair को हम यहाँ रख देंगे, and this is fluorine over here. So ये क्या structure according to Bent rule क्या structure आ गया इसका? That is not going to participate. So this is seesaw. Yes. Any problem in this? Clear? Another structure also you can see that like SF4. Let's do for SF4. Sulfur is 6 and fluorine is 7, 7 4 ja 28, 28 plus 6, 34. That means 4 bond pair and 1 lone pair, isn't it? Yes, that means sp3d. So the structure will be trigonal bipyramidal. In some books you will see that it is square planar also. Got it? Because all the fluorine will be at the square planar and the lone pair will be here. So बेसिकली जो बेंट रूल होता है दैट इज एप्लीकेबल इन द टीबीपी की केस में बहुत ज्यादा इंपॉर्टेंट होता है वो, ठीक है, गॉट इट। अदरवाइज भी हम लगा सकते हैं, तो दिस इज द करेक्ट आंसर अकॉर्डिंग टू द बेंट रूल। इफ यू विल फॉलो दिस इज द ओके। So SF4, if I am doing S like this, and there is a, so how many lone pair? One lone pair over here. Lone pair try to reside on the equatorial position. So we will not keep on this because these two are same and one lone pair only. So we will keep the lone pair over here. Okay, and it out. And the 4 fluorine, so we will keep this on this. So what is the shape of this compound? This is also seesaw. Okay, if there is one lone pair, it will be seesaw. If there is 2 lone pair, this is bent T shape. If there is no lone pair, it will be like simple. Yes, there is an except. अब यहाँ पे देखो, if I will say to draw the structure of XeF5 minus. See, so in this case, if you'll see that 48 and plus 35, 35, that is 44 upon 8, यानी कि it is 5 bond pair and 2 lone pair. 7, that means PBP, pentagonal bipyramidal, isn't it? So if we will draw the pentagonal bipyramidal, like this is the shape of XE. Here let me draw like this, yes, and this is axial over here, yes. So according to this is negative charge, that means it is having 2 lone pair, okay. So here according to this, the lone pair should exist on the equatorial position, isn't it? But ऐसा नहीं होता है. The lone pair exist on the axial position. Now you will say that the bent rule gone wrong, isn't it? You'll say that, you can say that the bent rule gone wrong, but it is not like that. Why? Try to understand the things. Let me open this. While explaining the bent rule, I have told you that it equatorial position, and why? Because of more space. It needs more space because it is bulky. Got it? More space. So if we will check this, in this case, the bond angle is 72. This one is 72. Equatorial position के बीच में 72. But if we check this axial one, 72, and this one is 90 degree. So here the bond angle is 90 degree. This is the 90 degree, and here it is 72 degree. Where it is getting more space? Obviously on the axial position, and that's why in this case this is like you can say that it is not following the bent rule, but actually it is also following the bent rule, and because of more space it will it will be on the axial position. Did you get that? Yes, समझ में आई बात? Any problem in this? Okay, so this is all about the bent rule. यहाँ पे ऐसा नहीं है. If somewhere says that कि XeF5 minus doesn't follow bent rule, your answer will be no, it's not like that. It is also following the bent rule, but वहाँ पे क्या होगा? It will acquire the position where it is getting more space, and on the equatorial position it is getting the less space, and that's why it will shift to the axial position. I hope it is clear. This is little bit out of your CBSE. So if there is any problem, if you didn't get it, please let me know. I will tell you, I will explain it again. So I hope it is clear, and so just go through with this video properly. Try to understand. If there is any problem, you can tell me. And okay, so that's it beta for today, and hope you will enjoy this. Enjoy your study. Thank you, class.